And in this talk I want to do some more codey stuff. Now, one of the things I mentioned when I was sort of telling you a bit about what I do and what I'm interested in, I told you a little bit about multi-paradigm programming. I'd like to just unpack this a little bit more and sort of just say more of what I mean about it, because I sort of want to just give you a sort of way to take aspect-oriented programming, which we're going to talk about in this talk, and just be able to sort of put it on the map somewhere. So you could sort of see a paradigm as an approach to solving a problem. We can sort of name a load of the big ones and just sort of look at what they are. So object-oriented programming is the one that's probably familiar to most of us. We build systems out of objects, and they have some state and they have some operations. And exactly what we call that state and those operations differs from language to language. We might call them fields, we might call them attributes, we might call behavior bits methods, or we might talk about message passing and so forth. But at the end of the day, what it all really boils down to is you have these things with a bit of state, and they have some behavior which operates on that state. Now, in the sort of world we live in, the sort of languages we often work with do what we call class-based object orientation. But if you sort of take OO and sort of go and search for its heart, then in a way inheritance isn't really part of that heart at all. It's just, classes aren't either. It's just one way of looking at objects. So object orientation is fairly broad, and we've realized it in a lot of ways, and it's a paradigm that I think that it's still very much evolving. There's still things in object orientation which are coming along. Has anyone heard of traits in Smalltalk, for example? Okay, so they are a new idea of a nice way we can factor stuff in our object-oriented software. So this isn't sort of these paradigms aren't things that we should see as, we can define it as exactly this today. It's nice to sort of draw a very broad sort of brushstroke on these things. Another paradigm that we probably are a little less familiar with is functional programming. Now, I don't want to confuse this with procedural programming. This is very different. In functional programming, the sort of big thing you have to do with your brain is you have to stop thinking about code and data as different things and just realize that you can pass bits of code around just like you pass bits of data around. If you can get your head to do that somersault, then you've probably just understood functional programming pretty well. The other idea is that it's all about sort of this kind of purity. So you have functions which take some values, operate on them, and give back a result. And functional programming tends to be very interested in what does and doesn't have an effect on the outside world, which is really great for parallelism. So if you've heard of Microsoft's F# language on the .NET platform, F# is a language that's very strongly influenced by the functional programming paradigm. And as a result, it's pretty nice for doing sort of parallel stuff, or I should say parallelizable stuff. So you write code, and you give the compiler enough information to go and say, oh, I can do this in parallel. Another type of programming that we do quite a bit is declarative programming. Declarative programming is kind of easy. We tell the computer what we want and leave it to go and figure out how to do it. I like declarative programming. Some languages tend towards embracing just one of these paradigms. I think it's fair to say that Java is very much into the object-oriented paradigm and sort of doesn't pay that much attention to the others. Functional programming, we have languages like Lisp, Meta language, Pascal. Anyone written any of those? Okay, there's a couple of hands for these. And then we get declarative languages. Prolog is sort of the classical example, but I've never done anything useful with that. The sort of most advanced Prolog program I wrote was able to confirm that my uncle actually was my uncle. But the sort of common ones we use are things like regular expressions. When you write a regex, you're actually writing a pattern to say, I want to match a bit of text that looks like this somewhere in this string, please try and do that. We're not saying how to go through the string character by character and do it. We're just saying what we want. SQL is the same. We're not telling the computer how to sort of join a couple of tables together and how to read the files from disk and so forth. We're just saying, oh, I want these bits of data back. For languages that are restricted to a small domain, it tends to be fine to sort of just embrace one paradigm. But a lot of general purpose languages seek to embrace more and more of them and sort of realize that that gives you a much richer language and a much more expressive way to do your programming. So C# has actually done pretty well on this. C# at its core is pretty object-oriented, but they've got some nice support for functional programming. So if you've worked with lambda expressions and you've started passing around lambdas, well, what you're doing there is you're sort of passing a bit of code around as if it was data. You're doing a little bit of functional programming in your C#. They also then introduced LINQ. So LINQ is very much a say what you want. So I want to get all the things from this collection where they have a property that's called, say, is valid that's set to true. And I don't have to sort of write the loop myself that goes through each of them in an if statement and so forth. I can actually start writing just some declaration of what I want. In JavaScript, there's a couple of them as well. So JavaScript is decidedly object-oriented. It's not class-based object orientation, it's prototype-based, but that's definitely a realization of object orientation. And it's also functional. So you can just pass functions around as if they were data. Of course, Perl 6, the language I'm hacking on the compiler for, is sort of all of these as well. So it has also a lot of these elements. The problem when you do this is actually that you don't really want to have programmers sat there writing code thinking, oh, I'm doing O now, and now I'm going to start doing functional, and now I'm going to do a bit of declarative. The ideal is you have a language where it's so effortless that you probably used all three paradigms on one line of code without even thinking about it. JavaScript is sort of an easy one to think about. In JavaScript, a function is just an object that you can invoke, and an object is just some state plus a table of functions. If you sort of think about it that way, then you can see how they've managed to sort of fuse these two paradigms. In general, though, they actually tend to want to be core paradigms of a language. They sort of draw out some very sort of big things and expectations of how your language is going to look overall, which is really why we have quite a challenge as language designers in trying to bring these different paradigms together into a coherent language. There's some other paradigms which try to provide solutions to some very specific challenges that our bigger paradigms sort of leave behind though. One of them is generics. Generics is also known as, or I should say, it's a form of parametric polymorphism. This is the idea that we want to reuse a bit of code, maybe a class or a function, and we'd like to safely be able to reuse it with different types. So we'd be able to say, okay, instead of writing a class that's sort of a dog list and another class that's a cat list, I'd like to write one list class which is a list of some type T, and then we can use it for dogs and cats. Aspect-oriented programming fits into this category of paradigms which tries to solve a problem that our sort of core paradigms sort of struggle with. So the first thing that I really want you to take away from this, aspect-oriented programming is it's not the next object-oriented programming, okay? It's just another little paradigm that we can use that sort of tries to address some things along with other ones, but that they don't do so well. So what's the actual problem that AOP wants to try and address? I think it's sort of safe to say that a lot of the time, we know that we need to implement a little bit of functionality, but just going and writing the core logic is never the full story. We sort of start off really simple. So, okay, this is a really simple bit of code. It's just taking some parameters, it's doing a link query, and it's doing some sort of changes to the object it gets back and sticking it back in the database. So it's just updating a blog post. Okay, maybe I misspelled duck in the subject line or something like that. So we sort of write that code, but we get extra requirements. We're told that we need to log the changes. We have a web service interface as well as a web interface, and we decide that we should push the security down. So we sort of have our check in the security. So can the user do this inside that? Then we sort of realize that logging costs a bit, so we don't really want to compile it in. We'll just sort of shove some conditional compilation in there. And then, of course, we realize to our horror that we forgot to do the exception handling, so we should do that and log our exceptions. So by this point, the code on the left over here, this is what I care about when I read this method. That's what this method exists for. But I have to find it in all of this. And there's a load of stuff in there which actually isn't related to the problem that this method is solving. Now, I thought long and hard about how to sort of elegantly express what's wrong here, and basically the phrase I came up with was, the factoring is crap. So I have to repeat these things probably in every single method in my data access layer. I probably always need to be doing some access checks, I always need to be doing some error logging and so forth. It's a lot of copy-paste. What if I screw that up? Okay, it's easy. I've done lots of mistakes where I had to copy-paste something and then I forgot to update part of it. And it's also a nightmare if we sort of want to change our logging framework. So we've tried to be good object-oriented programmers and factored our logging into one place and maybe even programmed against an interface and all of these things, but we've still actually coupled our code somewhat against that. And you know, that's kind of tricky. And it gets even worse if we get a new cross-cutting requirement. So for example, suppose that we had 20 methods and we decided, oh, we should have done exception handling in all of those. Then we have to go and stick it in every single one of them. So, that's kind of annoying. Our problem really is that no matter how we try and factor this in a sort of object-oriented fashion, we're still having to try and deal with these cross-cutting concerns, and they sort of get in the way and get all over the place, and we really like a way to sort of factor them out. And we can look at some possible solutions. So if we look at what our solution should be composed of, we'd like to write our cross-cutting functionality once. We'd only like to maintain it in one place. Okay, this is the dry principle. Don't repeat yourself. Well, then what we'd like to do is to be able to take this bit of functionality and just sort of have it sort of sprayed all over our code base for us. So it's sort of declaratively applied sort of to all the various places we need it. So I really want to just be able to say, here's a bit of logging functionality, please go and apply it to every single method in this bunch of classes. And that's it. That's all I want to have to say. I don't want to have to go copy-pasting all over the place. Now, you could say, well, okay, why don't we just write sort of our methods and then write a bit of code generation that uses this sort of as a template and goes and sticks in all the stuff we want, and we get a file out the other end and we compile that. In case, if you do this, the problem is that you need to have a really good sort of parser or your code generation is very fragile. You also have to maintain all of this. Developers have to know the templating language, know what's going on, and so forth. And generally, even though I'm a compiler writer, and you might think, oh, he'd love code generation, I actually view code generation as a last resort. When we write compilers, the very last step is code generation. Up until then, we actually keep everything in tree format, because code generation is sort of nasty. So we don't want to do that. We might then go and sort of lean on sort of higher order programming. We might say, well, what happens if we take the body of our method, we wrap it in a lambda expression, so it's just now a little bit of code that we can pass somewhere else, and we pass it to some other sort of bit of code, say a method, and this method does the logging, it does it wraps an exception handler around it, and in the try part of it, it goes and makes the call to this sort of lambda expression. So it's evaluated in the context we want, and we have all the functionality in one place. It's sort of okay, it's an improvement, but it still needs us to go and add a little bit of code to all our method bodies sort of inside of it, and we haven't quite managed to reduce the coupling. We've improved, but we've gone and coupled ourselves against this sort of other helper function. So we've only sort of solved the problem. So the other problem with this is if you want to compose two different bits of functionality, and that's when things start to get a little bit tricky as well. So this is the problem that aspect-oriented programming tries to sort of address. So whenever we talk about the paradigm, we have some sort of concepts that go with it. So when we talk about object orientation, we talk about methods and fields, classes, so forth. Likewise, we